next year. That's great.
All right. We're doing differentiation and integration of power series. So now that you know what a power series looks like, here is the general format. It's a to the n, which would be your a, and this is your r, x minus c, and we're raising it to the n power. You never saw the minus c because that's where it's centered at. All right? It's always been centered at 0. So now if it's going to be a to the x to the n, that's what you've been seeing. And now that generates this. Okay? We've been working with c equals 0. That's exactly what I said. Now if I want to take a derivative, it's an easy power rule. Okay? The power rule is, guess what we do? Bring down to n, subtract n by 1. There we go. Now if I want to look at what goes on here, it's the same as taking the derivative of each one of these things with respect to x. Check it out. This goes away, that becomes 1. Then this becomes 2 a2s. Okay, 2 a2s. This one goes away because remember that was a constant. So that's why I have just a1, because it's like a1x. This is like a2 this squared, so it's 2 a2s, then 3 a3s, etc. That's how it works with differentiation. Integration works pretty much the same way. If we integrate it, we just add 1 to the power and divide by that 1. And we add a constant on the outside. Or on the inside, doesn't matter. That constant gets added back. So it's basic power rules. And if I did that to each step, once again, if I take the integral here of a1, I get a1x, or x minus c. If I take the integral here, I get a2 this squared. So it works out. Let me do an example with you. So here's an example. I have a power series that says x to the n over n. Now find the first derivative. If I want to find the first derivative of this, it's just going to be, if I'm right, all right, I'm going to get my notes just to make sure I know what I'm doing, all right, is going to be the summation n equals 1 to infinity, okay, and this is going to be x to the n minus 1. I would multiply the outside by n, and the n's would cancel out. And that's what I would get. And this would be 1 plus x squared, etc. The original one, well, if I set x to be 1, it would be x. Then it would be plus x squared over 2 plus x cubed over 3. And if you notice, if I take the derivative of each of these terms, I get what's here. Okay? I get exactly, here's 1. Here's derivative here is x. Derivative here is x squared, etc. So you could take it of the whole general format, the general, or you can take it of each term. The integral, however, if I want to take the integral, it's just going to be something that looks like this. I add 1, divide by the same thing, so it's going to be x to the n plus 1 all over n times n plus 1. And then I'll add c to that. Usually we put the c on the outside. It doesn't really matter where you put the c, but we'll do plus c out here. So this will be, when n is 1, it's going to be x squared over 1 times 2 plus x, when it's 2, is x cubed, and it's 2 times 3 plus x to the 4th, and this is 3 times 4, etc. A lot of times I won't multiply it out. All right? And the last thing is the series. Well, I think I just found the series for this. This is this right here. I did that right there. That's the series generated. If you want a plus dot dot dot, enjoy yourself. All right? And that's really differentiation and integration. And you might say, well, where does it get used? It gets used in problems that look something like this. Arctan x. Okay, if I want the series generated by arctan of x, what I'm going to do is I know that taking the integral and the derivative undo each other, right? So why can't I do that? It's the same thing, integral and derivative. But now I can work with it because I know the derivative of arctan x. This is the same, this portion right here, if you will, this portion I'm highlighting, is the same as, ready? Just 1 over 1 plus x squared. Holy cow, that looks very, very much like something we can work with, all right? This 1 over 1 plus x squared, if you remember from a over 1 minus r, is where a is equal to, hold on, it connects here. A equals 1 and r equals negative x squared. So now this guy is the same as n starting at 0 for infinity, and this is going to be negative x squared to the n power, which is now remember, it's the integral of that, so I still want the integral of that stuff. I didn't take the integral away, all right? So it's going to be equal to the 1 plus negative x squared plus x to the 4th. But remember, I want the integration of these. Maybe I want to integrate each one separately to lead me to a general equation here. All right, so when I integrate, I get in green, the integration would be, well, this would be x, this would be negative x cubed over 3, this would be plus x to the 5th over 5. I wonder if it works out, this is the first term, or I should say 0th term, first term, second term. I find an equation. The general term is going to be this. N equals 0, infinity. And let's see if I know what I'm doing. So, I would like to take the negative out. I would like to rewrite this. I'm going to rewrite this as, because I'm going to do it right from here. This is what I would do, right from here. Negative 1 to the n power. Because that's what this is when I distribute that. Times x to the 2n. Well, how do we take the integral of this? When I want to take the integral, the negative 1 doesn't change. However, this just add 1 to the power and divide by that same 1. And this, my friends, right here, is the general format of what I'm doing. You never do it to the negative 1 because that means it's just switching signs. And if you look, let's see if it works. When I plug in 0, I get, when I plug in 0, I get x over 1, which is just x, and negative 1 to 0 is x. When I plug in 1, I get x to the 3rd over 3, and then minus 1, because that, remember, every time n is odd, you're going to get minus. It's going to be alternating. And there you go. So, what did I do? I found, here's a recap. Of some of these problems, I take the integral and derivative, but I know the derivative, so I do that. I looked at it as a series, put it here. I knew I had to take the integral. I started making terms. So here's the series generated by it. Here's the first 3 terms, if you will. And now I needed a general term. I always take that negative and make it a negative 1n, because now I can do the power rule or the antiderivative and just add 1, divide by this new power. There it is. I got one for you to do tonight. I want you to try the ln of 1 plus x. I want you to try it the way I just did it. All right? I would take the derivative, I want the directions to give you better directions. I want the general format, general, and first 3 terms. And they'll probably say non-zero, because sometimes they turn out to be 0. All right, so first 3 non-zero terms. That's what I want to see from you the next time I see you. All right, enjoy. We're going to spice it up a bit on our next slide. So enjoy this while you can. All right, take it easy.